Okay, here we have another IB question. Again, from the same paper from May 2025, and that's from time zone 2 and question 6. That's a question for a total of 7 marks. And all of those things that are very, very important to be able to identify whilst you're doing work. The marks are also important, and the marks corresponding to each sub-question, they're also very important. So, anyway, let's start. Consider the function f of x, which is equal to the square root of x squared ln x plus 4 minus x squared. That's my f of x. Again, x belongs to all real numbers, but also there's the addition that x has to be positive. This is a key thing because if we end up with solutions or multiple solutions where some of them are for x smaller than 0, we're going to have to reject them based off that condition. The other reason that this exists is because if you see inside the function, what we have the ln x, and we know that ln x, right, it is defined for x bigger than 0, therefore that's why this appears where it appears. Let's just move on from that. So for 1 mark, which means it has to be an easy thing, one method, and also it's a show question. Show because the answer is given, right? So that the distance L between the origin and any point on the graph of f is given by that. So because the answer is given, that's why you're only going to get 1 mark, and that's going to be for the method, right? Of course, you're going to have to show that the distance has been given by that, but don't expect that you're going to get a mark for something that's already been given to you. So let's just pick apart that thing a little bit. So I know it's a paper 1 question, which means it's a non-calculator, so you don't really know what the graph of f of x. However, let's assume that there's a graph which just goes a bit like that. It just doesn't really matter. And let's assume that this is my f of x, right? Any point on that graph, and let's put it a point P here, it's going to have coordinates x, comma, f of x. Because that's what the f of x sort of kind of like, says, that the relationship between the x value and the f of x value, they're given to you by the f of x. Or another way, you could have done it as x1 and f of x1, if that helps you more. So that's going to have to make x1 this one and f of x1 this one. Yeah? Whether you have it with x1 or x, it just doesn't really matter. Now, the origin is that 0, 0, which means if I want to calculate that distance here, right, there's a couple of ways to think about it. The one it would have been, let's put it method A, by applying the distance formula. And the distance formula is given to you in the formula booklet. Another way to think about it, it would be by doing Pythagoras' theorem, because what we have here is a right angle triangle. That side, it's going to be equal to f of x, and that side is going to be equal to x, or x1 or f of x1. It just doesn't really matter. So if I do Pythagoras' theorem for that triangle here, assuming that the hypotenuse is the distance, then I'm going to have d squared is equal to x squared plus f of x and all of that squared. Yeah? Now I want to find the distance. The question here is using L to represent the distance, so we're going to go with that. That L, it's going to be equal to the square root of x squared plus f of x squared. Now the f of x, as you can see up there, is the square root, so let's just square root it first and write the x squared times by ln x plus 4 minus x squared, and then square root it again. But we're also going to have to square that because that's the f of x squared. That means that the squared with the square root, they're going to disappear. So what I'm going to be left with is going to be the outside square root only, with x squared at the front, and then plus x squared times by ln x plus 4 minus x squared. What is actually happening here, that x squared and that x squared, that will cancel out each other, and I'm going to end up with L to be equal to x squared times by ln x plus 4. which is basically what I was asked to show, right? And then you can write QED to show that you have demonstrated what you were asked to do. And that would be the end of it. Be careful, that's quite an important part. The distance formula exists in your formula booklet, and you should be able to locate it. And then the distance formula, becomes the square root of x2 minus x1 and all that squared, plus y2 minus y1 and all that squared, for the distance between 2 points, let's say A, x1, y1, and a point B, x2, y2. Now, for the second part, which has a lot more work, but the looks of it, because it's only it's for 6 marks, as you can see here. We're gonna have to find the x-coordinate of the point of the graph of f, for which is the closest to the origin. So let me that clear up a bit the space here. You can always go back and rewatch that video if you wanna have that space, but I think it's gonna be important for me to be able to show you how we're thinking about that part. So let's calculate that. Let's remove all of that. So now that we have the distance formula, or we know that the distance L, right, is equal to the x squared ln x plus 4, which is something you could have used even if you hadn't answered the part A, right? That's the whole idea here. We have a hence command. Hence command means that you're going to have to use part A no matter what. Otherwise, you're not following the command term, which is the hence, and therefore you're going to be kind of like marked down. So we wanna minimize that part. The way we work with that, because we want to minimize it, right, is by finding the derivative and by finding whether the derivative is equal to 0, because we want to find the minimum point, and just moving forward like that. Now, I could find the derivative, because essentially what I have here is an L of x, is a function in terms of x, which is equal to the square root of x squared ln x plus a 4. What I could have done, I could find the derivative of that, which I can, or I could square both sides so I can make my life easier when it comes down to finding the derivative, because this would become minimum where the L squared is minimum. So if I square that and make it L squared of x is equal to the root of x squared ln x plus a 4 and all of that squared, that will cross out the square root and that will give me just with x squared ln x plus 4, which will make my life a little bit more easier, because finding the derivative of that now would become the x squared ln x plus 4 derivative. Now, the derivative of 4, I know that is going to be 0, so I'm not worried about that part, but you need to be able to identify that x squared ln x, you're going to need a product rule, because you have two functions, right? And let me just remind you the product rule. When you have f times by g and you want to find the derivative of that, essentially you write twice what you see, and then for the first product you want the derivative of f, and for the second one the derivative of g. So what I'm going to get here is going to be x squared ln x plus x squared ln x, with the difference that I want the derivative of the x squared for the first product, and then the derivative of ln x for the second product. And of course I'm going to add plus a 0, which is the derivative of 4, as the derivative of any constant is always going to be 0. Now that's going to give me 2x ln x plus x squared times by the derivative of ln x, which is ln x derivative is 1 over x times by 1 over x. If I cross out the square with the x over here, I'm going to end up with 2x ln x plus another x. Yeah? And that is the derivative of the square distance. Yeah? Right. Now, to identify where this is going to be either minimum or maximum, I'm going to have to put it equal to 0. So, putting the 2x ln x plus another x is equal to 0. It looks a bit complicated, but it's not. You always have to try to factor and put it equal to 0. So that's going to become x times by 2 ln x plus 1 is equal to 0. Now, here we're using the principle that a times by b is equal to 0, then that means that a is going to be equal to 0 or b is equal to 0. So we ended up with x is equal to 0, which I'm going to reject because if you look at the beginning, we know that x is positive. So that's going to be rejected. Or 2 ln x plus 1 is equal to 0. Let's just add the page here to have a bit more space. Which means that 2 ln x is equal to negative 1, which means ln x is equal to negative 1/2, right? Now, I want to solve for x, and the way to do that, because I want to get this x out of the ln x, I'm going to apply the inverse function of ln x, which is the e to the power of x, because e to the power of ln x, that's going to give me just an x, yeah? So e to the power, I'm going to end up with x is equal e to the power of negative 1/2. That is the same as 1 over e to the power of 1/2, or otherwise 1 over root e, or otherwise root e over e. All of those things. And because e is 2.7 and blah, 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 the rest, that means that this is positive, right? And because this is positive, that's going to become my solution. Last thing before I move, because remember that was like for 6 marks, so there's a lot of work to be done there, right? You're going to have to go back and reread the question and see whether we have answered fully or not. Because 6 marks, there are going to be a lot of marks applied for the method, then applied for the actual result, and we did quite a lot of work here. So hence, which means use part A, which we've done, find the x-coordinate of the point of the graph for which it's closest to the origin. What we found over here, we found the x-coordinate. Sometimes they ask you for both coordinates, and if this is not the case, then we would have to plug that value into the f of x.